Hello, everyone. In this episode of our video series about design and development of conveyor belt systems, we will be discussing a polyurethane flexible conveyor belt to splice and begin by defining what is a conveyor belt to splice, about polyurethane specifically as a material used to splice conveyor belts, quality tests associated with um, these splices that are made out of polyurethane, and also how to make actually the polyurethane splices. We are at the beginning stages of this research project. The results are not satisfactory yet, just so you know, but it is good to know about the process involved in achieving the final satisfactory results. So let's just start by defining what is a conveyor belt. um, there's a need for something to join the two ends of a conveyor belt. In a manufacturing plant where the conveyor belts are made, a few kilometers of conveyor belt is not made in one piece. Therefore, there is a need for a kit to join the two ends of a belt. So imagine in the middle of a desert at a mining site, you have 28 kilometers of conveyor belt. Just for the logistic reasons, it is impossible to make all that 28 kilometers of the belt in one piece, because how is it going to be transported from the plant to the mining site? Just imagine that. So therefore, that conveyor belt comes into pieces and it has to be assembled on site. That process where the two ends of a conveyor belt are joined, that's called the splice. Um, from a mechanical perspective, it is under a lot of tensions and a lot of stresses are involved in that concentrated splicing regions. That is why we're putting so much focus on the splices specifically. There are mechanical and chemical types of splicing. Mechanical ones are normally faster in terms of installation, and chemical splicings normally take longer period in the scale of days because of the curing time required for that chemicals to set. Materials used for splicing, mechanical splices can be metallic, can be polyurethane, can be rubber, and chemicals are normally some sort of adhesive material that would join the two ends of a belt together. Um, Jumping to the next part of this presentation, and then later on, we'll show you how the quality tests are done and actually how to make this polyurethane. But before that, it is essential to know what type of polyurethane exists in the market. So personally, when I was started to study polyurethane, I was started to purchase something that was rigid, a rigid polyurethane, and it was not foam. But my intention was to make something flexible because I thought polyurethane is polyurethane, and it can be become any flexible splice out of any polyurethane. But then I realized that there are multiple types of polyurethane. The one that we are after is called polyurethane elastomers, also known as polyurethane, also known as polyurethanium elastomers, are highly elastic materials used in application requiring flexibility, resilience, and also abrasion resistance. So that's exactly what we need for a conveyor belt splice. Rigid polyurethane, on the other side, are used for thermal insulation in construction, refrigeration, and other application. They have excellent insulation properties, structural strength, and low density. Other types of polyurethanes can also be used for adhesive and sealants. It has a wide variety of applications across the industries. That's why this material is just phenomenal. The main quality test that we are going to conduct on our polyurethane splice are the tensile strength, because the conveyor belt is constantly under tension. It is important for us to know whether that splice can handle all those stresses and tensile tensions. So a typical tensile strength test will be conducted. I'll share you the result. I'll share with you the results of the test that we have conducted. These are preliminary studies, not even near the satisfactory results, but um, that's the part of the process. So, and there are learnings in that as well. Abrasion resistant test based on DIN 5351-6 standard method refers to the amount of material that would be scratched and taken off the splice or the conveyor belt whenever it is subject to abrasive material. So the test is conducted in a way that there's a rotary drum where your material, in our case, the polyurethane, will be um, subject to that under that rotary drum with a specific amount of friction. And after a certain period of time, let's say 1 minute, 2 minute, because of the friction and those abrasive interactions between the drum and the polyurethane, a few grams or few tens of grams of the polyurethane will be scratched off, um, and then the remaining mass of the sample will be measured. If it's less than a certain threshold, it would tick off and becomes an abrasion resistant type of splice, and that's what we need. There is also another test, Shore A hardness test. It's a measure of flexibility, how hard it is. It's a needle that is going to be penetrated in a material. There are multiple types of Shore hardness tests. This time we're using Shore A. We do also have Shore D test for harder type of material, but since we're dealing with polyurethane, Shore A test suffice. Um, the process involving making polyurethane splices are starts with having a mold first of all, because it's a two-part liquid. If I want to show you, this one is actually the rigid polyurethane, part A and part B. So if you can see, it's a liquid phase type of thing. So you're going to need a mold to first of all mix those part A and part B, then pour it in a mold um, to allow a few minutes or few hours, even depending on the type of mix, for it to cure. Chemicals, like you've seen, there are two parts. Then we will discuss what type of chemicals are involved, the formulation specifically, what percentage of part A has to be mixed with part B, and for how long should it be mixed and left in the mold. The curing conditions are also important. Some polyurethane samples, especially the one that I've used, started to generate CO2 gas, and because of the viscosity levels of that liquid, that generated gas was entrapped inside the sample, resulting into a lower tensile strength. So, ideally, we want to have a vacuum chamber where the curing happens. There are other notes in the scientific papers where heat curing is recommended because it improves the mechanical strength and properties of polyurethane samples. Um, let's say between the temperatures of 70 to 90 degrees. Most of the literature would suggest that the highest tensile strength is achieved when samples are cured between 70 to 90 Celsius degrees. Then we move on to the quality checks. And if you are based in Australia, you want to have an accredited testing body to test your samples, because if you want to present your products into the market, definitely the consumer needs to know whether that material has been tested by an accredited body. First step is to design your molds. Where do you want your polyurethane liquid so that it would set and make your splices? I've made these ones using a 3D printer and a 3D design. Um, a few considerations when you're about to make this design is the ease of de-assembly. Imagine that your mold uh, your polyurethane is already set and it is time to take the polyurethane sample out. So you want to ideally make that mold in a way that it will be easy to take the polyurethane out. This one was my first try, and it was not the best one because it took me a few while to get the polyurethane sample out. As you can see, there is no space around it to um, pull the prepared sample out. But this one was the second try. I've tried to make something modular and a bit longer. I actually tried that one as well. It was much easier to bring out the polyurethane splice when it was set, because as you may imagine, I could just easily break this and take the polyurethane sample out. Um, you may want to also think about some sort of reinforcements when it comes to designing your polyurethane conveyor belt to splice. In that example, in one of my trials, I've tried to use a steel mesh, um, but I couldn't exactly get an accurate result because polyurethane first failed under the tensile test, and basically the mesh was not getting engaged into the tensile strength of the polyurethane sample. So yeah, there are other multiple types of creating molds such as CNC engraving, depending on what type of material you are choosing for your molds. This one is a PLA. It's a recyclable or recycled plastic that is often used for 3D printing. And also another important note about chemicals that are used for polyurethane. You normally get um, two liquid phase, let's say, bottles, part A and part B. This one is not a flexible elastomer polyurethane. So this sample will give me um, a really hard polyurethane that was not flexible at all. What we are after here when it comes to splicing um, materials for conveyor belts, we are after flexible elastomer polyurethane. And based on the mix ratio, so for example, with this one was a 1-to-1 ratio, and it gave a really hard piece of polyurethane at the end. But there are other types of polyurethane based on how the chain is designed that will give you flexibility and also tensile strength as well. So two of the things that you can actually modify to achieve your desired strength and also flexibility will be the mixed portion. So let's say um, if you put in 50 grams of part A and 100 grams of part B, the flexibility and the strength would change. The other thing that you can modify and achieve different results would be the temperature of um, the temperature during the curing process. Because what happens is that normally when these two parts are mixed, CO2 gas is released, and if the liquid has a high viscosity, sorry, a low viscosity, those CO2 gas generated as a result of the reaction will get entrapped inside your polyurethane sample and eventually results in a lower mechanical strength. So you got to think about how to get those bubbles out when these two liquids are mixed. There are two ways basically. One of them will be by increasing the temperature so that the viscosity will be higher. It will be easier for the gas bubbles to run out of the polyurethane sample. And the other way is um, by doing the curing inside a vacuum chamber. So that's probably the next step for me to do because I haven't get to the point where the tensile strength and um, other mechanical properties would be satisfied. So yeah, I'm probably going to use a vacuum chamber and a heat pad. underneath these molds so that I'll be able to increase the temperature of the polyurethane, making it easy for the bubbles to just escape from from the sample. Example formulation is like this. We're going to have polyether or polyester. So the difference between these two, the first row is a soft part of the mix. MDI or TDI is those are the parts responsible to majority of the mechanical performance. The first part is those polyethers and polyester. The difference between those is the resistance against chemical attacks. So one of them would deteriorate faster on the even on the rain. So at the exposure to water, one of them, I'm not sure which one exactly, but it's just a matter of a little research for you to know which one is better for your specific application. And then we have butadiol, if I'm pronouncing it right. That one is a um, so what the third item does is that it creates chain between MDI and polyether or polyester. You need a catalyst and also additives as well. So one of the additives that I think I'm going to be using later on is a degassing component to limit the amount of CO2 gas generated because it's just no good for the tensile test. And these are the typical mix ratios that you may need to um, have a good polyurethane, flexible polyurethane sample um, with an acceptable tensile strength. Example results that we are going to expect from a polyurethane splice is as such, we need something between 10 to 50 megapascal on the tensile strength. Elongation at break should be in that range. Sure, a hardness between 70 to 95. So it's a gauge whenever you push it down on the material, the gauge will show you what the hardness rate is. And the tear strength is normally between 30 to 80 kilonewton. Thank you so much for watching this video series. I hope that you learned something and it helps you in splicing conveyor belts. In the next episode, um, we're going to do some improvement, particularly um, with the curing condition of the polyurethane so that we will get improved results. Thank you again.